Morning everyone. It is 2:23 in the morning, not the best time to be doing math, but we're going to be going through the A-level H2 math paper from 2022, paper 1. Uh, there's a saying in Chinese that on the first day of Lunar New Year, the children should stay up late for the longevity of their parents and their elders, and that's precisely what I'm doing tonight. So, let's do the paper. First question is simultaneous equation involving complex number. So we'll take the first equation and make W the subject. W is negative 1 plus iz divided by 2. And then we use this to substitute in the equation. So I get 2 minus I z. If I multiply this by I will get minus I negative z divided by 2 is 6. Multiply both sides by 2, I get 4 minus, I'll expand out as well, 4z minus 2iz minus I plus z is 12, so that you get z, so you get 5z minus 2iz is 12 plus I, so you get 12 plus I divided by 5 minus 2I. We'll multiply by the conjugate. Okay, the numerator will be 29. Okay. 60 minus 2 is 58. Okay, and then the imaginary part is 24 plus 5 is 29. And this is just 2 plus I. Okay, and then you can figure out what W is. So you get 2I minus 1 plus 2W equals to negative 1. Then you will realize that actually W is just negative I. Okay, so there you go. Z is 2 plus I and W is negative I. That's the first question. Okay, second question, McLaurin's. We're given f of x is tangent inverse of root 2 plus x. Find the first and second derivatives. Okay, to find the first derivative, you just differentiate the inside function, so you get 1 over 1 plus the square of the inside function, so root 2 plus x squared. That's it. Then for the second derivative, it's a chain rule application, so this is a minus 1 power. So get you bring down the minus, you get negative 2 on the bottom, and then you need to differentiate the actual expression on the inside, which will give you just the 2 root 2 plus x. Yep. So what this should look like is 2 root 2 plus x divided by negative 1 plus root 2 plus x square. Yeah, pretty much. Okay, hence find the first three terms of the Maclaurin series of f of x. Okay, f of 0 is tangent inverse root 2, which is not a nice number. I think it's 0.955 trace f. Okay, f prime 0 is 1/3, which is 0.0333 3sf. Okay, then the second derivative is 2 root 2 divided by 9, which is 0.314 3sf. So fx is approximately f0 plus f prime 0 over 1 factorial plus f double prime 0 divided by 2 factorial. So this is 0.955 plus 0.333x minus 157x squared, and yeah, that is your Maclaurin series for tangent inverse root 2 plus x. Third question, parametric equations of a curve are this. Using calculus, find the gradient and normal to the curve when t is 1/3 ln 2. Okay, so we find dx dt and dy dt. Dx dt is, well, when I differentiate e power 3t, I get 3 times of that. When I differentiate 2e negative 3t, I'll get a minus 3. Okay, so this will cancel. So what I'm just going to get is a 3 on the outside, 3 over 2, and this will give me e to the power of 3t minus 2e to the power of negative 3t. And similarly, dy dt, you'll notice that actually it's almost the same, except that the plus was a minus. So you get 3 half e to the 3t plus 2e to the negative 3t. Okay, so you get dy dx, which is dy dt times dt dx. So you get e to the power of 3t plus 2e to the minus 3t divided by e to the 3t minus 2e to the minus 3t. Okay, then you get dy dx. T is 1/3 ln 2. What's this? Okay, so you get e to the power of ln 2, which is just 2, and then 2 plus 2e to the negative ln 2, which is half. So 2 plus 2 times half, which is 3, then the bottom is 1. So you get 3. So therefore, gradient of normal is negative 1/3, negative reciprocal. Okay. By considering x squared and y squared or otherwise, find the Cartesian equation of the curve. If I square x, x squared is 1 over 9 e to the 6t. If you square this, you'll notice that you actually get the 2 times the 2 terms, right? You actually get a term independent of t. You'll get plus 4. It's not 1 over 9, sorry, it's 1 over 4. Just realized. Okay. Okay, plus 4e to the negative 6t. Y squared, it's the same as x squared, but there's a minus, so you get e to the 6t minus 4 plus 4e to the negative 6t, which you may have noticed is the same as x squared minus 2. So that's the equation of the curve. X squared minus y squared equals 2. Okay, what is the restriction on the value of x? And you know that this curve is a hyperbola, but there's a restriction because your x has to be positive, right? Yeah, because e to the 3t and 2e to the negative 3t, they're both positive, so it has to be like a right-sided hyperbola. So therefore, your curve can only lie on the part which has the right vertex, and for that reason, x is greater than or equals to root 2 is your restriction on the value of x. Fourth question. Okay, show that the derivative of cotangent x is negative cosecant square x. So, to do this, we shall use 1 over tangent x. Okay, so you will get a negative 1 power, so bring down to minus 1. So you get minus tangent square x at the bottom, but at the top you have secant square x. So then if I multiply the top and bottom by cosine square x, I will get negative 1 over sine square x, which is negative cosecant square x. Okay, show that sine 2x tangent x is 2 sine square x. Okay, well, sine 2x is 2 sine x cosine x times sine x divided by cosine x. Okay, the cosine x will disappear. You're left with 2 sine square x. Hence, find the exact value of the following expression. Okay, so I'm going to integrate pi over 18 to pi over 9. Cosecant 6x cotangent 3x dx. How does it seem related? Well, there's actually a bit of a sneaky thing. Cosecant is the reciprocal of sine, cotangent is the reciprocal of tangent. So pi over 18 to pi over 9, 1 over sine 6x, okay, tangent 3x dx. And you'll notice that this is the same as my sine 2x tangent x, but I replace my x by 3x. So this becomes the integral from pi over 18 to pi over 9 of 1 over 2 sine square 3x dx. Very cool, right? I'll bring this out. So this is the integral from pi over 18 to pi over 9 of cosecant square 3x dx. This is a bit tricky because we have if we integrate negative cosecant square x, you'll get cotangent x plus c, but this is 3x. So we actually need to divide this by 3, and in fact we need to take a negative also. So this is negative 1/6 of cotangent 3x. So the powers are tricky. Pi over 18 to pi over 9. Cotangent 3 pi over 9 is 1 over tangent pi over 3, which is, well, it's 1 over root 3. Okay, minus cotangent 3 pi over 18 is tangent pi over 3, which is root 3. Okay, and this is, well, you'll get negative 2 root 3 over 3, then you put the 6 on the outside. So the negatives cancel out and you get 2 root 3 over 18, which is root 3 over 9. Okay, cool. Fifth question. The line with this equation y equals to mx is tangent to the curve with this equation x plus 8 squared plus y minus 14 squared is 52. Should the m satisfies the following equation? This is a quadratic curve, so if you remember your A mats, actually if you sub in y equals to mx, then it will work if you show the discriminant. Okay, so x plus 8 squared plus mx minus 14 squared is 52, which gives us x squared plus 16x plus 64 plus m squared x squared minus 28mx plus 196 is 52. Okay, m squared plus 1 x plus 16 minus 28m x, oh sorry, this square. Okay, then I get 64 plus 196, which is 260 minus 52, right, 260 is 52. So I plus 208, and this is 0. Okay, so let discriminant greater than 0, discriminant equals to 0 actually. So this means 16 minus 28m square is equals to 4m squared plus 1, 208. Okay, this means 4 minus 7m square, so I can actually take out a 16 here. It gets to 52 m squared plus 1. Okay, so this implies 49m squared minus 56m plus 16 equals to 52m squared plus 52. Simplifying, 3m squared plus 56m plus 36 equals to 0, which is what we wanted. A and B are points on that curve. The tangents of A and B intersect the origin. Find the coordinates of A and B. Okay, so we have the two values of m that we can find by solving this equation. So if we factor this, how do I factor this? 3m n, 3m plus something, m plus something. Okay. Looks like it is 2 and 18 equals to 0, which would imply that m is negative 2/3 or m is negative 18. Okay. So if I take negative 2/3 for m equals negative 2/3, okay. What I will get is 4 over 9 plus 1, which is 13 over 9, x squared. Okay, 16 plus 56 over 3, which is 56 plus 114, plus 208 equals to 0. Wait, no, 100, not 114, 104, I think. Okay. Which would imply 13 over 9. Okay, you can actually factor this out, so this turns out to be x squared plus 24x plus, okay, this is 144 equals 0. And if you complete the square, you'll notice that it's exactly a perfect square. The only solution is x equals to negative 12. And y is, well, it's this times negative 2/3, so it's 8. Okay. Okay, for the other one, for m equals to negative 18, 325x squared, 16 minus 28m, so 28 times 18, which is 280 minus 56, which is 224. 224 plus 16, 240, plus 208 equals 0. No, sorry, 260, I think, because 280. No. 16 minus 28m is, m is 18, so 280 minus, oh, 560 minus 56, 504, 520. Okay, and everything can be divided by 13 here. So 13, 25x squared plus 40x, it's not m, it's x, plus 81, wait, no, sorry, 16 equals 0. And this also only emits one root. X is negative 4 over 5, and y in this case would be negative 18 times this is 72 over 5. Okay, so therefore your A is negative 12, 8, B is negative 4 over 5, 72 over 5. Okay, so that's question 5. Question 6. The function f is defined by the following. Describe fully a sequence of transformations which transforms the curve y equals to 1 over x onto this curve. Okay, so ax plus k divided by x minus a. Firstly, let's split this fraction. So I'm going to write this as ax minus a squared divided by x minus a plus a squared plus k divided by x minus a. The a factors out, so I get a plus a squared plus k divided by x minus a. Okay, so my order of transformations will be translate a units in positive x direction. Okay, my second would be scale by factor a squared plus k parallel to the y-axis. Then 3, translate a units again in the positive, this time the y direction. Okay, so those are the 3 transformations I need to make. Find f inverse. Okay, let y equals to f of x. So one has y minus a equals to a squared plus k x minus a. Make x the subject, so I have x equals to a plus y minus a. Sorry, a squared plus k y minus a. Okay, and therefore f inverse x is a plus a squared plus k divided by x minus a, which is f of x, interestingly enough. Okay, so it's called a self-inverse function actually, there's a name for this. Find f2x. Well, f2x is just x. Okay, and there's no need to state the domains for these functions because the question didn't say so. Find f2023 1 in terms of a and k. Okay, f2023 1, well, this is f2021 f21, which is f2021 1, which for the same reason as f2019 1, until you eventually get just f of 1, which is, well, let's simplify it, it's a plus k 1 minus a. Okay, 1 minus a, provided a is not 1. Okay, yeah. Question 7, a curve has this equation. Show that dy dx is this and find the coordinates of the turning point. Okay. For this, dy dx, we apply chain rule. So start with keep the x minus 3, differentiate ln x, I get 1 over x. Okay, minus 3 x negative 4 ln x. Okay, so this is x power negative 3 and x power negative 1, so you get x power negative 4. So you get 1 minus 3 ln x divided by x power 4, which is what was 1/3. Okay, let dy dx equals to 0 to find the turning point. So ln x is 1/3, which implies that x is e 1/3. Okay, and y is, well, it's y is, okay, so 1 over e, then ln e 1/3 is 1/3, so it's 1 over 3e. Okay, so the turning point is e13 1 over 3e. Okay, find the exact area enclosed by C, the x-axis, and the line x equals to 3. For this, you may want to do a very quick sketch of the curve. but very quick because the sketch is not worth any marks because the question did not ask for a sketch. But essentially what the graph will look like is something like this. Okay, so this is 1, and you want to find the exact area enclosed by C and 3, so it's this region here. Okay, so you know that the entire region is above the x-axis, which is great, because that means that you can just do an integral directly 1 to 3 of ln x divided by x cubed dx. How about I write it as it originally was? Okay, how do I find this integral? Okay, well, you can just use integration by parts, right? LIATE. My u shall be ln x, and my v prime is x power negative 3. So when I take uv, integrate 1 over x cubed, you get negative half x squared. So you get minus half x minus 2 ln x. Okay, and then when you integrate the next one, you keep u again, you keep v prime again, or rather you keep v, and now you take u prime. So this is now going to be plus half the integral, because when you put by minus and you put the negative here, it's a double negative. So x minus 2, and now there's a 1 over x, so it's x minus 3 dx. And this goes from 1 to 3. And if you do this, you will get minus half x minus 2 ln x. Okay, if I integrate this once again, I will get minus quarter x minus 2. And this goes from 1 to 3. And this gives me, well, negative ln 3 minus 18 minus 1 over minus 1 over 36 plus ln plus 0, and then plus 1 9, no wait, 1 quarter. Okay, and then 1 quarter minus 1 over 36 is good, 9 over 36, 8 over 36, which is 2 over 9. So you get 2 over 9 minus ln 3 over 18. So that will be the exact area in terms of square units. Okay. Question 8, this integration. Find 2x minus 1, x squared plus 2x plus 1. Okay, so the insight here is x squared plus 2x plus 1 is actually x plus 1 squared. So I'm going to write it this way. Now, the derivative of x squared plus 2x plus 1 is 2x plus 1, 2x plus 2. So I shall write it in this way, 2x plus 2 divided by x squared plus 2x plus 1 dx minus integral of 3 divided by x plus 1 square dx. Okay, and if I do this, I'll get 2 ln, actually this is x plus 1 squared, right? So this is going to be, there's no 2 outside actually, it's just ln, oh wait, it is 2 because I can do 2, okay, never mind, I'll explain this later. But I get ln x plus 1 square. There's no need for modulus, cos of course is always positive, minus, okay, now if I integrate this, I will get 3 over x plus 1 plus c. But now I should actually simplify this. I can take out the 2 from the power and the ln. Now this may not be positive anymore, so I will put in x plus 1 in modulus to make sure that that is the case. 3 divided by x plus 1, finish with the plus c. So that is the indefinite integral. oh wait, this is a plus, sorry, because of the negative power. Find the exact value of this integral. Integral from 0 to 2 mod 2x minus 1 divided by x squared plus 2x plus 1 dx. Well, 2x might, well, the bottom is always positive because it's only 0 when x is negative 1 and otherwise it's positive, so no problems. So the usual approach is to split the integral. 2x minus 1 is negative for x less than half. So what I like to do for this is just think of it as adding the negative, sorry, putting a negative sign on that part and then putting a positive sign on the rest. So I am integrating from half to 2 of 2x minus 1 over x squared plus 2x plus 1 dx. Subtract the integral from 0 to half of the same thing. Okay, so this is 2 ln mod x plus 1 plus 3 over x plus 1 half 2 minus, okay, same thing. Okay, which is 2 ln 3 plus 1, okay, minus 2 ln 3 over 2 minus 2. Yeah, okay, and again minus 2 ln 3 over 2 minus 2. If I put in 0, this becomes 0, and then minus, so it becomes plus 3. Okay, simplify, so I bring all the constant terms together. The independent of ln terms all disappear actually, so you're just left with 2 ln, it's just left with 2 ln 3 minus, okay, 3, and then there's 4 over 9. So 3 times 9 over 4. Is it? No. Sorry, it's 9 over 4, so it's times 4 over 9. Okay, 3 times 4 over 9 is 4 over 3, so 2 ln 4 over 3 is your answer. Question 9, part 1. An arithmetic series has the first term a and common difference d. d is not 0. First, third, and 15th term of the series are the first, second, and third of a geometric. Find d in terms of a. So the second divided by the first, which is a plus 2d divided by a, must be equals to the third divided by the second, which is a plus 14d divided by a plus 2d. Cross multiply, a plus 2d squared is a squared plus 14ad. A squared plus 4ad plus 4d squared is a squared plus 14ad. Okay, so I get a squared cancel out, so you get 4d squared equals to 10ad. Then d is not 0, implies that you can divide d on both sides, so you get 4d is 10a or d is 5 over 2a. Okay. A geometric series is first term sine theta common ratio negative cosine theta, where 0 theta pi over 2. Show that the sum to infinity in the series is tangent k theta, where k is a constant. First, we show that the sum to infinity does exist. For 0 theta less than pi over 2, we know cosine starts at 1 and goes down to 0, so we get negative 1 less than theta less than 0. Sorry, cosine theta less than 0. Therefore, mod negative cosine theta is less than 1. And so, sum to infinity exists. It is given by sine theta divided by 1 plus cosine theta. Okay, and sneaky thing you can do here, sine theta is 2 sine theta over 2 cosine theta over 2. 1 plus cosine theta, don't forget, is 2 cosine squared theta over 2 minus 1, so you get 2 cosine squared theta over 2. The cosines will cancel, and the 2's will cancel also. and you're left with sine theta over 2 cosine theta over 2, which is tangent theta over 2. So k is half. Given that theta is pi by 3, find the exact sum of the first 7 terms of the series. Okay. Sum of first 7 terms. Okay. So it is the first term, so sine pi over 3. Okay. Then we have 1 minus negative cosine pi over 3 to the 8th power. Sorry, to the 7th power. Divide by 1 minus the actual thing. Okay. And this is root 3 over 2. 1. Okay, when you take the 7th power of this is minus negative 128, so 1 plus 1 over 128. Divide by 1 plus half. Okay, and this is 129, 128 divided by 3 over 2, which is 43. Then you times 2, right? So it's root 3. So just 43 root 3 over 128. Yep. Pretty weird, but I think it's good. Okay. Question 10, a curve C has this equation. Ax plus b plus a plus 2b, a and b are real constants, a is greater than 0, b is not negative a over 2, x is not 1. It's given that c doesn't have a stationary point. Use differentiation to find a relationship between a and b. dy dx is a minus a plus 2b x minus 1 squared. So we need dy dx to be not equals to 0, and because a is positive, this means we need a plus 2b to be negative, so that dy dx is always positive. So we need this to be less than 0, and from here we can obtain a variety of relationships. I could say, for example, actually I could just leave it at that, and that would be a correct answer. But I could say a less than negative 2b, for example, is a possibility. There are many different equivalent ways to express the condition here, but yeah. Given now that b is negative 2a, sketch C. So if I put in b is negative 2a into my inequality, I will get negative 3a is less than 0, which is clearly true. So there's no stationary point on this curve. And what are the intercepts? Well, we know that there's an asymptote at x equals to 1. But another key feature would be the y-intercept. The y-intercept is when x is 0, so you get b minus a minus 2b. So you get minus a minus b, but b is negative 2a, so you just get a as the y-intercept. So let's draw an example of that. Let's say this is the asymptote. Okay, and let's also draw an asymptote line. So this depends on a, but essentially it will look something like at 1, the value that it should be, so-called, what is it? How do I say this? the oblique asymptote is ax minus 2a. Okay, so it passes through the point 2 and 0. So just check that. Okay, then draw the curve. Make sure that it cuts through A. This will be a bit hard for me to draw, but essentially it looks something like approach the asymptote. Okay, so this is A, this is 1, and this is, it will approach this other asymptote and it will go this way. I'm having a hard time today. But essentially it will look something like that. Y equals to, in this case you will get ax minus 2a plus, okay, minus 3a, right? Yeah. So you get y equals to ax minus 2a, then minus 3a. Okay. So you get x equals to 1, and this is y equals to ax minus 2a. Yeah. So this is what the curve would look like, something like this. It's not perfect what I drew, but you get the idea. So on the same sketch, just sketch the graph of y equals to ax minus a. Okay, so that is just a parallel line that passes through 1, 0. So that's like a here. Okay, this line y equals to ax minus a. Okay, hence solve this inequality. This happens to be the case a equals to 1. So x minus 2 minus 3 divided by x minus 1 equals to x minus 1. So this means minus 3x minus 1 is positive 1. So 3x minus 1 equals to negative 1. And this gives us x is negative 2. Okay, so this here is negative 2. And to solve the inequality of the curve being less than or equals to the line, I want the curve to be below the line. So for the solution of the inequality from graph, x is less than or equals to negative 2 or x is strictly greater than 1 is the answer to the inequality, because those are the ranges of the curve where the curve lies below the line. Yeah, so it's actually in special case a equals to 1. I think it's quite interesting. Okay, so now we come to the two real-world context question. A gas company has plans to install a pipeline from a gas field to a storage facility. One part of the route for the pipeline has to pass under the river. This part is a straight line. Points are defined relative to the origin. You get the x, y, and z directions. P is this coordinates, Q is this coordinates. The length of the pipeline PQ is 939. P is below Q. What's the value of, find the value of P. Okay, so the magnitude of PQ, and in fact I'll consider the magnitude of PQ squared, so that I can find 1136 minus 200 squared equals to, sorry, plus 92 minus 20 squared. And I know I'm kind of writing them in the wrong order, but it doesn't matter in this case because it is squared, so it doesn't matter. So this is 939 squared. If you do the math, this is 881280 plus p plus 15 squared equals to, oops, 881721. Wow. Okay. So that is to say p plus 15 square equals to 441, which is 21 square. So p is negative 15 plus minus 21, so minus p is negative 36, or p equals to 6. Reject, because p has to be less than negative 15, it has to be below q. So p is negative 36 shall be our answer. A thin layer of rock lies below the ground. It's a plane. You have 3 points in the plane. Okay, find the Cartesian equation. So whenever you have 3 points on the plane, you can find two vectors which are parallel to that plane and cross that to get a normal vector to the plane. So vector 1 parallel to plane is, so I'll take the second point minus the first point, so I get 100, negative 400, and negative 50. Is it? Yeah. Okay. Which is, of course, I can just take it as 10. Actually no, I'll take it as 50. 2, negative 8, and 1. Negative 1. Vector 2 parallel to the plane. I'll take the third point minus the first point. So I get 200. Negative 940. And 30. Negative 30. And then this is 10, 20, negative 94, and negative 3. Yeah. Okay. Normal vector is negative 281 cross 20, negative 94, negative 3. Sorry, negative 1, 94, negative 3. Okay. So cross 24, 94. Okay. Minus 70. 20. Okay. 14. Negative 14. And negative 188 and 160, so negative 28, okay, which is minus 14, 512. Yep, so plane is r dot 512 is any point on the vector dot 512. Any point on the plane dot 512, 400, 600 minus 20. 400, 600 minus 20 dot 512, which is 2560. So therefore 5x plus y plus 2z is 2560. Hence find the coordinates of the point where the pipeline meets the rock. I don't have a lot of space left on this page, but the direction vector of PQ direction vector of the pipeline is, if I go from P to Q, or I go from Q to P, in fact, I can do that too. Let's go P to Q. Minus 936, I think minus 72 and 21, right? Okay, which is 3 times of negative 312, 24, negative 24 and 7. So I find the vector equation to be 200 minus 312 lambda, 200, 20 and negative 15 will be our fixed point, and plus 7 lambda, okay, dot the direction vector, or the normal vector rather, and this is 2560 for some value of lambda. Let's try to find the solution of this. So one will get 990 minus 570 lambda equals to 2560. And of course you will notice that in this case actually, hey, lambda is negative 1. Okay. So you can find that the coordinate of intersection is 512, 48 and what? Sorry, not 48 but 44 and negative 22. So this is the pipeline intersect with the rock is here. Finally, find the angle of the pipeline between the points P and Q makes to the horizontal. So when you're doing line and plane, is sine. So this is just sine inverse. Okay, so you need the direction vector of the PQ, which is 312 24/7. So you get mod minus 312 minus 24/7 dot 001. That is the normal vector to the z plane. Then you just divide this by mod minus 312 minus 24 and 7. Okay, and yeah, and that's your answer. So it's 7, so square root 312 square plus 24 square plus 7 square, which is actually 313 exactly, interestingly enough. Your calculator will give you the answer in radians, but don't forget to convert to degrees, and you will get 1.3 degrees as a 1 dp. Okay, so yeah. Last question is differential equation. Okay, so we are modeling population growth now. They attempt to model population P at time t days using a differential equation. Initially, the population is observed to be 50. After 10 days, it is 100. The first model assumes that the rate of change of population is proportional to the population. So that is to say that the original model here is dp dt equals to kp. Okay, so that is to say, if I separate the variables, integrate 1 over kp dp equals to integrate 1 dt. So that is to say 1 over k ln p ln mod p equals t plus c. and that P is, if I multiply by K, so I get AEKT, then A is plus minus E to the KC. Okay, then yeah, then from here you get when T equals 0, P equals to A, which is 50, T equals to 10, P equals to 50E 10K, which is 100. So therefore, K is ln 2 divided by 10. Okay. So it is, so therefore in this case, your model for P is actually 50 times 2 to the T over 10. So yeah, it's a very nice model, very nice answer for this. Solve this differential equation. This is constraints of population growth. dp dt is refined to lambda p times 500 minus p. So this is the Verhulst differentials equation. Logistic growth, and it is a bit more reasonable in real life, and there are some reasons for that lah. Okay, and you'll see why in a minute. So separating the variables again, one arrives at 1 over, sorry, let's make it a bit smaller, 1 over lambda p 500 minus p. If I integrate this side with respect to p, this is the same as integrating 1 dt, so I get 1 over lambda. Okay, so partial fractions. How do I do partial fractions for this? So you can do cover-up rule, of course. So if I do a over p and b over 500 minus p, if I put in 0, I'll get 1 over 500. Let me try and do the cover-up rule. So a over p plus b over 500 minus p. Okay, and this equals to 1. So if I put in the 0 into p, my a is going to become 1 over 500, and if I put 500 the p, it will be the same for b. So it turns out that I can actually write this as 1 over 500 lambda. Integrate 1 over p plus 1 over 500 minus p dp equals to t plus c, which implies, and here's a fun thing to do, I'm actually going to rewrite this as minus 1 over p minus 500, so that I can do, and multiply both sides by 500 lambda, and I should not use c, I should use d, because I used c earlier. Okay, this gives me ln mod p divided by p minus 500 is 500 lambda t plus e. E is 500 lambda d. Okay, and this means p over p minus 500 is, again, I can do b e power 500t, 500 lambda t. Okay, and in this case b is plus minus of e to the power of e lah. Okay, yeah. Okay, Now I sub in some conditions. When t equals to 0, we have b equals to 50. The original population is 50. Divide by 50 minus 500 equals to negative 1 over 9. When t equals to 10, we have 100. We have negative 19 e to the 5000 lambda equals to 100 over 100 minus 500, which is negative quarter. So what is lambda? One over 5000 ln 9 over 4. Okay, so one has p minus 500 divided by p, which is 1 minus 500 over p, being equals to, okay, this is minus 9e. Okay, so I put lambda here, so now this is 505,000, so this is 110 negative t ln 9 over 4 divided by 10. Yes. Okay, and let me simplify this a bit. So this is ln 9 over 4, so this is minus 9 over 4 to the negative t over 10. Okay, then 500 over p is 1 plus 9 over 4 to the negative t over 10, and finally p is 500 divided by, yeah, that 1 plus 9 over 4 negative t over 10. And you can verify for yourself that when t is 0, p is 500 divided by 1 plus 9, which is 50, and when t is 10, p is 500 divided by 1 plus 9 times 9 over 4 negative 1, which is 4 over 9, so 500 divided by 1 plus 4, which is 100. Okay, so this is the solution. It's very nice, although many people are telling me that's actually very ugly, maybe because they didn't simplify the exponential terms. Using the refined model, state the population of the species in the long term. So as t tends to infinity, obviously p tends to 500, because this term tends to 0, so you just get 500 divided by 1, which is 500. Okay, how is this an improvement on the first model? Well, it suggests that population will stabilize at fixed level, whereas first model predicts infinite growth, right? Because it's just an exponential model, and this is not realistic. Okay, so yeah, so the second model is more realistic, I would say. I think that's just the way they want to put it across. Okay, yeah, so that's it. Oh, Jesus Christ, how did this end up all the way here? Okay, okay, that's it for the 2022 H2 Math Paper 1. Overall, I think it was fairly manageable, although I had some of my friends tell me it was a bit challenging. We'll take a look at the paper 2 someday, very soon. I personally think paper 2 is harder than paper 1, so hopefully we'll be able to go through it soon. I'll edit this video and hopefully you guys can hear me. I had to talk a bit softly. Again, it's 3:40 in the morning. Very unholy time to do math, but uh, yeah, that's all for now. And turn up the volume of the video. I hope you guys turn up the volume of the video if you couldn't hear me. But yeah, thanks for watching, guys. I'll see you all next time.